So it will be very, I mean, whatever the things you have learned about ETL tools, okay. Okay. So it will be the same from the in the DBT also. So we call it as a data build tool. Okay. So here, I mean, in the first class, we will be like, studying about what will be the structure of traditional data teams, how would they, I mean, how they'll be getting the data and how they'll be transforming the data. Okay. And then we will talk about the ETL and ELT parts in this particular class. Okay. And we will discuss about the necessity of an analytics engineer. So you might have heard of it, roles like data engineer and data analyst. So we will talk. I mean, we will talk about an analyst engineer, which will be very specific for DBT. Okay, and we will discuss about how DBT fits into our daily routines. Okay, and finally we will talk about the structure of DBT, how it is like in DBT we will be dealing with models, sources, tests, I mean deployment, all those kinds of things. We will be learning about them in the next classes. Okay.
Okay.
Anybody wants to anybody has some specific requirement on some topics or something? Okay, fine. Okay. So we'll just talk about the traditional data teams. So how many are working on now? Like I've heard 2 people are working now in some different projects, right? So yeah. So usually the traditional data teams will have typically 2 roles. Like one is data engineers and one is data analysts. Okay. So most probably data engineers are responsible for building the infrastructure, hosting the data, getting the sources, doing the transformations, and whatever the cleansing of data. So everything the data engineers will be doing, and they'll be prepping up the data in such a way that data analysts can use that final data. Okay. So usually the data engineers will be using data tools like SQL servers and some programming languages like Python, Java, or something. For some orchestration or job scheduling, they will be using some other kinds of jobs, right? And coming to data analysts, so they will be dealing with most of the stakeholders, like as an end users. Okay, so they will be knowing like what the requirement would be and how the data should be structured. Okay, so that they can pull out some reports, Excel reports or dashboards on top of that. On top of that final data that data engineers has built. Okay, so typically the skill set for the data engineer would be like any ETL tool or any programming language, okay, and a database tool. And for data analysts, it would be any Excel skills. You might need some Excel skills reporting or any Power BI or Tableau dashboards. And a bit of SQL is also required. So whenever some analyst has to pull some data into reports, a bit of SQL data, I mean, expert is also needed. Okay. So how DBT comes into picture between these data analysts and data engineers is, so we do have a bit of gap. Like we do have 2 different teams here. So only when data engineer can can put some final data into some tables. Okay, so only then the data analyst can pull the data and put it in a form of dashboard for the stakeholders. Okay, so it will be like we need like 2 people or 2 teams to do that. So if it is let's say consider an MNC organization, we'll be having large kinds of data sets and we'll be having more number of reports considering the size of the company. Okay, so we typically need 2 teams, data engineering team and data analyst team. Okay, but so when DBT has come into picture, so DBT will be helping people or teams to integrate both of them, whatever the work data engineers are doing and whatever the work data analysts are doing. Okay, because data engineers can set up the infrastructure and can do the cleansing of data. They can prep up the data for the final dashboards. And data analysts have the knowledge of how the data should look like for the final stakeholders. Okay. So based on these two concepts are integrated in DBT. Okay. Any doubts here?
Oh, no, all good.
Okay. Yes. So as I said earlier, whatever the data we have from the sources to be able to put that into our final tables. So we will need some ETL tools. ETL as an extract, transform, and load. So we have some ETL in market. We have some ETL tools for SSIS. We have some Informatica tools out there. Okay, so we have some cloud-based tools also there out there, and some of them are like on-premise tools which can use on our SQL servers or Oracle servers. Okay, so all these ETL tools can be are used by data engineers typically, and they use them to transform the data. Okay, so these ETL tools are third-party tools. Okay, so where every time we have to load some data into our final tables, we have to extract the data from the sources and you have to push it to ETL tools, and we transform the data there in the third-party ETL tools, and then we will be loading the final data into our databases or data warehouses, right? So anybody who has the experience of ETL, working on ETL tools, can easily understand this. Okay. So extraction means, I mean, sources means we can have different kinds of sources. Sources can be Excel files, CSV files, or XML data, or JSON data, whatever it can be. Okay. So on top of the data, so every time we get some raw data, so we just have to transform that. We cannot use the raw data because it is raw data is just a data dump of everything. Okay, but for an analysis purposes, we would not need everything there. Okay, we would need only some part of the data. Okay, so for that purpose, we have to transform the data into our into our table structured type, where our users can read that data and where our analysts can use that data. Okay, so we have to transform that data and then we have to load that data into our final tables. Okay, so as I said, these traditional ETL tools require extra skill set. Okay, or I am extra skill set as an so somebody might work on SSIS, somebody might work on Informatica, somebody might work on some other cloud center. Okay, these are the extra skill set we need for a data engineer. Okay, so and for these jobs, I mean, let's say if this ETL is an daily process, we have to set up as a schedule as a job, and we have to make sure that it should run daily. For that also, we might need some other third-party tools like Airflow DAX to schedule whatever the jobs we have created. Okay, so when it is large data set, so this becomes tedious because transforming the large data sets in a third-party tools will be time taking. Okay, so since they are third parties, since they are not internal, so the third party tier two tends to pull the data into their servers and then transform there and then push it back into our systems. So it is a tedious process when we have a large data set. So right now, so what's happening is most of the its organizations are moving towards the cloud-based data warehouses. Okay, so where they can easily scale up the uh, size of the databases or data warehouses, however they want. Even they can scale up or scale down. Okay, and it is all purchase based. Whatever the storage you want, you can just purchase it, and whenever you have the less requirement, you can just scale down your usage. Okay, so with this, I mean, this concept of new cloud-based storage and cloud-based compute is the basis for our DBT. Okay, so based on these concepts of cloud, so our DBT has been invented. Okay, so anybody has any doubts, or if you want to stop me or somewhere else, you just tell me. So somebody who might be working on already on this team, so it might be boring. So these all for the people who are very new to DBT and very new to data teams. So this is all just the background for those people. Okay, is it clear?
Yes, clear, please.
Okay, fine. So with these new cloud-based services, so what we can do is, so we can just directly take the data from sources, take the raw data from sources, and we dump it all there. Because on the cloud services, the storage is much cheaper when compared to the storage on our on-premises databases. Okay, so we can on these cloud services, we can just take the raw data and just dump it into our databases or data warehouses on cloud. Okay, and then we will try to transform the data. Okay, so please understand. So what is happening? What is happening in the traditional data warehouses is, so first based so we are having constraints about storage, and we are having constraints about compute capacity as well. Okay, so on the on-premises systems, the storage and computer services are fixed. So to be able to scale up them, so it would be cost involved, and it would take much more time. Okay, and it would take much more. It is a tedious process to be able to scale up the on-premises systems. But with the invention of cloud-based inventions, to be able to scale up the storage or to be able to scale up the compute capacity, it is very easy. It will be done in some minutes. Okay, so that's where the concept of ETL has changed to ELT. Instead of extract, transform, and load, so we would be doing extract, load, and then transform. Okay, so but we should understand the catch here. Any doubts from ETL to ELT? What is ETL and what is ELT?
Yeah, no doubt.
Okay, yeah. So this is the concept of ETL and tool. So with the on the on-premises servers, so we would be doing ETL process, and with the invention of this cloud services, we are just shifting to ELT process. Okay, so we will talk about where DBT comes in this ELT process in the further discussion. Okay, any doubts here? So, it's okay. Anyways, we were talking about the concepts of data warehouses, right? So, let me talk about data. What is a data warehouse? How we are using that? Okay. What are the data lakes? What are the kinds of things we are using there? Okay. So, data warehouses are not, like just a kinds of databases with the additional power of computation. Okay, so you might have heard of databases are just to store the data. Okay, they will not have any compute capacity, or no, they won't be able to do any transformations on top of by themselves. But dataverse is something so which can store our data and can has the power of computation also. Okay, typically to be able to interact with the data warehouse, we would just use SQL language on that. We would just query the data warehouse using the SQL queries. Okay. So databases are nothing more than, just a performance engine, and then let's do analytic workloads on top of that. Okay. And we might use the data warehouses just for reporting and dashboard purposes also. And it, while loading the data into the data warehouses, so we should keep in mind that the data should be well structured and clean, and it should be the final data. Okay. So in the data inside the databases, so you can do number of transformations, whatever the cleaning of the data you can do. But while loading the final data into our data warehouses, it should be well structured and it should be clean. Okay. Because all the data, all the dashboards, or all the dashboards, or all the BI works or ML works would be done on top of this data warehouses. Okay. So we will not be able to load all the unstructured data, or raw data into the data warehouses. Okay. And so we have one more concept of external tables here. External tables. Okay. So as I said, with the invention of cloud services, the storage, the cost of storage and the cost of compute has drastically come down when compared to on-premises services. Okay. But be it a cloud services or on-premises services, both of them has their own issues, design issues, I mean to say. Okay. For cloud, sometimes you might have to pay the upfront cost for higher nodes, for higher compute, for higher compute capacities. And even if for the storage also, even if you have opted for large amount of storage, but if your analytics loads are higher, you might end up paying high loads, high cost for that. But although we do have the concept of auto scaling on the storage and capacities, but sometimes we may not be able to meet the peak workloads whenever we have more loads of work. Whenever we need more compute capacity, we might not be able to meet the needs. So to be able to overcome this situation, so cloud services has come up. All the cloud services have come up with the concept called external tables. Okay, where our data would be in somewhere in the cloud, Amazon S3 or Azure Blob Storage. Okay, our data would be sitting there, and our whatever the compute capacity would be sitting in some other place. Okay, so basically what we are doing is we are just decoupling the storage and compute part. Okay, so that we can easily scale up the storage and compute services whenever we need. Okay. So these external tables are just on the cloud and will be stored on a serverless service. Okay. And so anybody has any idea about data lakes here?
No.
Data warehouses, anybody are working on data warehouses right now?
Sorry, can you come in?
You guys said you're working on some Snowflake only, right? I think I have
Yes.
Snowflake.
Yes, I have idea on data warehouse, but I don't have idea on data lakes and all.
Okay. So as I said, so the data warehouses inside the data warehouses, so we will be keeping only the structured data. Okay. So why? Because all this structured data will be used by our analyst people, people who are, or your organization hierarchy. So to be able to make some decisions. So in the data warehouses, we cannot put the unstructured data. Okay. So that would be the final data which your hierarchy or some decision makers can use that data. But coming to data lakes, so data lake, it can be a dump of different kinds of data. It can store semi-structured data or unstructured data or even structured data. Okay.
Okay.
So it is just the basic difference between data warehouse and data lakes. Okay. So it can be, unstructured as in, if you want to store the data about some images or some audio files or some videos or anything. Okay. So whatever the data it is, you can just store in the data lake there. Okay. On top of the data lake, so we will be doing some kind of transformations, and then we will be loading that data into warehouses. Okay. By using some third-party ETL tools. So we would be making that unstructured data or structured data into structured data, and we'll be loading that final structured data into the warehouses, so that that data can be used by the reporting teams or data science teams or machine learning teams. Okay. So if I talk about the data lakes, okay. So the famous on-premise one would be like HDFS, Hadoop Distributed File System. That would be the famous one for the on-premise data lake. And coming to the cloud services, we do have Amazon S3, and we do have Azure Data Lake also. So both are AWS and Azure also providing the data lakes, which is S3 and Azure Data Lake. Okay. So these are the differences between data lake and data warehouse. Okay. Okay. So let's see how our DBT is fitting into this ETL and ELT part of the data teams.
So
Okay.
one question.
Yes.
Yeah, DBT works with only Snowflake or any other databases?
It has various range of data sources, not only with Snowflake.
Okay.
We can integrate with all kinds of cloud services. But we'll be able to connect with on-premise also, but it is majorly recommended to coordinate with the cloud services. Okay. Any doubts? Any more doubts?
No, they are all good.
So are you guys able to see my screen?
Yes.
Okay. Yeah.
No.
No. Let me reshare it. Is it now?
Yes, yes. Yes, yes.
Everyone?
Yes.
Yeah.
Yes.
Okay. So let's see how our DBT will be fitting into our modern data stack team. Okay. So usually, as I said, we will be performing the ETL process on our raw data to be able to push the final data into our data warehouses. Okay. So we do have this data sources. Okay. And from data sources, we will be loading the data into our data platforms. Data platforms, as in, in on-premise, I can say it as a SQL Server or Oracle, and on cloud services, we have the Snowflake, we have Redshift. Okay. So we'll be able to push the data into those data warehouses from the raw data. There's a data sources can be anything: XML files, JSON files, CSV files, or Excel files. Okay, so this is just basically a raw data. Okay, so based on the domain of your organization, you will be getting different kinds of data. Okay, so let's say if your company is an e-commerce company, you will be getting the data about different products, the discounts, the MRPs, and like whatever the e-commerce site you have. So how many people has visited that your site? How many clicks are made done? So how many purchases are made, like that? Based on the domain of your organization, so you might be getting different kinds of data. Okay, so whatever you're getting from your website or something, so whatever the data you're collecting, so that would be a raw data. Okay, on top of that raw data, so we have to do some transformations, and we have to prepare the data so that our hierarchy or the analysts can use the data to make some better decisions. Okay, to be able to push the data from data sources to data platforms. So in between, so we are using something called loaders. So these are the third-party ETL tools which we will be using generally. Okay, so by using these loaders, so we will be transforming the data from data sources. The data will be pushed to the loaders first. On the loaders, we will have different jobs, or we will have some different packages where we will be transforming the data, and the final data will be pushed to the data platforms here. Any doubts here?
This is ETL process you were saying, right?
Yes, this is the traditional ETL process. This is how it works. Okay.
Sure. Okay.
Okay. So on top of the final data warehouses where the final data is available, so this final data can be used by BI teams, or for some ML processing, okay, or for some operational analytics. Okay. So this is the final data which can be used by multiple teams. Okay. But so now, in contradiction to the traditional ETL process, so where our DBT comes is, so our DBT comes on top of the final data warehouse. Okay. So here from data warehouses, so the data would be directly loaded to the data platforms here. Okay. So data would be directly loaded to the data platforms. And on top of the data platforms, so we will be doing, DBT will be performing the transformations. Okay. So here, so why DBT is recommended for the, while using the traditional ETL tools is, so the time taken for the transformations would be very less, because generally what the regular ETL tools does is, so they will be pulling the data into their servers first. Okay. And then they will be transforming the data in their servers, and then pushing the data into the final data warehouses. Okay. So that includes a lot of time, and that includes lot of compute cost as well. Okay. But while using DBT, with the DBT, so after loading we can use, we'll be just directly dumping the raw data into the data warehouses. So why? Because all our storage part is on the cloud, so where the storage very cheap. So, but when we are using the on-premises services, like let's say we are loading the data, or data warehouses and SQL Server. Okay, so on-premise SQL Server. So on-premise SQL Server will be having storage constraints and compute constraints. Okay, so that's why we cannot load the direct raw data into our data warehouses. So we have to cut down the data. We have to remove the unnecessary parts, whatever is coming from the raw data. So we have to cut down all the unnecessary data, and we have to clean the data first, and then only we can load the final data. So let's say we are getting some and 1 million records per day as a source. from data sources. So after doing all the cleaning up, after doing all the processing on all the transformation, we might end up with just some 50 to 600,000 records out of 1 million records we receive. So we might just end up with 50 to 500 to 600,000 records. So when compared to the raw data, it is much lesser. So to be able to manage the storage in the final data warehouses, we would be doing that. Okay, before loading to the data warehouses, we will be cutting down all the data. But since we have moved to the cloud data warehouse now, let's say we have our data warehouse is Snowflake. So since the storage is much cheaper when compared to the on-premises storage, okay, so we will be just directly dumping all the raw data into our cloud databases. Okay, and on top of that, data warehouses or databases, we will be doing the transformations, and we will be creating new data inside the data warehouses. Okay, clear how we are doing the ELT and ETL here?
Yes, but in case of like if we are using the DBT, because there is a possibility of duplicate data in the cloud, right?
Yeah, so we see we are just doing select statement, and where we are just pushing the data in the same data warehouses. See, whenever we push the data from data sources to the final data warehouses directly, so we would be putting them in some kind of staging tables. Okay, so those will not be our final tables.
Okay.
We will not be using those tables for our decision making or reporting purposes. On top of those staging tables, so we are doing some transformations using DBT here. Okay, and we would be creating some views or some final tables. Okay, the data analysts or the ML teams can use those final tables in our data warehouses, not the stage tables. Okay.
Okay.
Clear?
Yes, clear.
I have a question. Yeah. So in general, so in Snowflake, for example, if you are, let's say I'm ingesting data in Snowflake from S3 bucket using Snowpipe. So in that scenario, we will be using external stages as the S3 bucket, right? Now, my understanding is when you push the data from using a Snowpipe into a raw table, so in general, what I mean in my project, what we do is after we push the data into the raw table, we perform transformations and then move into the facts and dimensions table. So DBT comes into picture before that step where we move the data from raw to the facts and dimension table, correct?
Yes, exactly.
Okay, yeah, makes sense. Thanks.
Okay, and so the one more thing we can one more thing which is favorable to DBT is, so here in DBT we don't have to worry about the DML and DDL part of the queries. Okay, because here we are not going to create any table, create a kind of use any create statements or insert statements here. So most of the things in every models, so we will just be dealing with the select part of the queries. Okay, but in traditional ETL tools, so first of all, we have to create one tables here in the data warehouses, and the data types and the structure of the tables should match with whatever the data we are receiving here. Okay, and then also if there is any discrepancy between the data, table structure, metadata, or the data types, so there are high chances that your jobs might fail. Okay, every time, right? But here, so we are just directly pushing the raw data to data into our staging tables in the data warehouses. Okay, so here we don't have to worry about the DML command, DDL structures here. Okay, and we will be just writing a select statements while transforming the data in DBT. Okay.
One question.
Yes.
When having the data into a staging area, the DBT will gonna take care all the processes related to creating the tables and respect to DMLs. This is what you are
DBT
saying?
will not take care of that. Okay.
Huh?
DBT will not take care of that. So in DBT, what we are having is for the transformations, we are just using select statements. Okay.
Okay.
We are just using select statements. So whatever let's say we have somewhere around 10 transformations from raw to final data. So all these 10 transformations will be based on the select statements.
Okay. And the final table layout, we need to define it, right then?
Yes, the final table you have to define.
Okay.
The final table you have to define.
That means for each transformation, what are the select statement we are gonna give? Okay, internally DBT will gonna create the stage table for that.
So internally the DBT will have not the stage table, we call it as models here. Okay. So for every transformations, we have different models. Okay. On top of those models, so we will be working, we'll be working with the data to create the final data set. Okay. So if you see here, I'll just show you here. So if you see, so whatever the green ones you see on the left side of the things, so those are all the sources. Okay. Those are all the sources. So whatever the things you see in between the blue, so those are all models. Okay. So in models, what we do is we try to write a logic based on select statements. Okay. And each model will be, some models are dependent on the previous models. Okay. If you see in the first line, so we have created first one transformation, and that transformation will be used by the next model. First model will be used by the next model. Okay. So like that. So there in DBT, a data lineage will be created from source to the next transformation, to the next transformation, and then to the final table. Okay.
Okay.
Is it clear? So instead of creating, more number of stage tables in between, so we are just creating models here. Okay. So let's say I can say this, not exactly as a view, but what in a view we will just have the metadata, right? We will not have the data. Usually in a view we will not be storing any data or any records. So a view, so there will be for every view there will be a base table. Okay. So whenever you query a view, whenever you perform a select statement on a view, so that view will take the data from the underlying table, right? The same way, so with the models are, so the models are we built on top of some tables. Okay. So this one, the first one particular model will be a base for the second model. Okay. So in the second model, we will be referencing the first model here. Okay. Any clarifications here? Okay. So for every, for every project or for every task we do, so this kind of data lineage diagram will be built by the DBT itself. Okay. And one more thing is, so we do not have to worry about the documentation, So what are the sources we are using? What are the transformations we are applying and to where the data is loading? So which model is dependent on which model? So we don't have to worry about the documentation part when it comes to DBT. Okay. So we do have a concept called documentation. Okay. So whenever you give some some valid and required inputs to the DBT, it will automatically generate the document for you for this particular data lineage. Okay. You don't have to worry about the documentation of this particular transformation. And then coming to the deployment, so we do have the option for deployments also. So where we can schedule this data lineage, schedule these DAGs. Okay. And they can run, we can schedule them for weekly, daily, or hourly runs. Okay. So this is the final data lineage thing, data DAG thing. So we are going to get after connecting to all sources, doing the transformations and the final data. Okay.
So DAG is a collection of like multiple workflows which we have like in Informatica, or like it's a just one workflow or one job set.
So it's not about a job set. No, I mean we can. Overall, the DAG is one entity where it will have where it will have different sources and destinations. Okay. So
Okay, so
the sources can be your Snowflake things, and another sources can be some other views or some other Excel files.
okay.
Yeah. So this is a whole DAG where will be able to deploy this DAG and we'll be able to schedule that.
The scheduler will be kind of on-premise scheduler, or it will be scheduled with like another
It will be
like
scheduled on DBT cloud itself. It
hmm?
will be not an on-premise. It will be on cloud. Okay.
Okay. But like
Yeah.
the scheduler, like the in traditional way we have Airflow and like UC4 at
See, these
such
are all
kind
the
of
third-party things.
yeah.
Okay.
Uh, so
So,
will
but
that
this is
support that?
uh, I don't think so because it has its own deployment center. It has its own
Okay.
deployments and it has its own cloud. So DBT can run the jobs on itself by itself.
Okay.
Okay.
Okay. Okay.
Yeah. And one more thing is, so while while you create the models or while you create a transformation, okay. So there is an option of testing your models as well, whether whatever the model you have built is performing well or not. Or else if you have, let's say you have created some unique keys and let's say you have put some constraints like not null, okay, in those transformations. So you can test the models whether it is working fine or not according to the given test. So for tests, so those are, I mean, no, we have to predefine the tests. There are no generic tests are there and user tests also. User tests are also available. So for user test, you can ask the DBT to do some kind of particular tests. Okay, you can give the condition, and then you can ask the DBT to test it on that particular model, whether that model is working accurately for that given condition or not. So we have option of testing the models also. Okay, so mostly, so we can do testing of the models. Okay, we can do deployments. Okay, we can connect to different sources. Okay, and the best part is we can easily document these models whatever we have built. Okay,
Yeah,
so this is the major part where DBT is getting highlighted in the market now.
yeah. One more thing.
Yeah.
So DBT supports which type of language? Like it can support Java, like or SQL only.
So mostly, most part of it would be SQL, okay, because we'll be mostly dealing with select statements for transformations.
Okay.
But there are some cases, I mean, we can use some files, program files. We can use that script here. I believe we cannot directly use the script. So, but we can use the files for that.
Can you give the overview of this course? I mean, like what are the topics you will cover, and like is any projects?
Projects as in, we'll be giving you a project. I mean, the normal project. So when I'll be guiding with the project, so that project will be available online as well. Okay, but I'll be guiding you to how to achieve whatever the things you have to do in the project. So here we will be so we will be dealing with setting up of DBT and how we can use GitHub to back up our models or back up our queries, whatever we do. Okay, and we will be dealing with how to create models, how to test them. Okay, and how to prepare a documentations on top of them, and how to connect to different sources, and how can we write different test cases. Okay, and finally, we will be dealing with the deployment of all our tags here, all of our data lineages. So these are all the high level parts which we are going to cover. So if you don't have anything, so we will just wind up this class, okay, and we will meet in the next class. Okay. Thank you guys. Bye. See you.
Thank you.